So what we're going to be doing with section 5.6 is really not a lot of new stuff. We're going to be taking all of the stuff that we've learned this unit and applying it into eventually actually sketching the graph of this function. So to do that, we have 8 things we're going to find before we get to the sketch. I'm going to do all of those 8 here, and then the sketch will come separately later. So with A, first derivative, accompanying sign analysis, derivative of this function, 4x cubed plus 12x squared. In order to do the sign analysis, we need to find when the derivative is going to equal 0. We can take out a 4x squared from that. Split that off into 2. And we find that x equals 0 and x equals -3. So when we construct the number line, we'll have a point at -3, we'll have a point at 0, and at those 2 points this function will have a value of 0. Need to find the sign in each of the 3 sections we've got, so I'll pick -4, I'll pick -1, and I'll pick 1. Evaluate the derivative at each of those points. So at -4 we end up with a negative. At -1, and I'm going to skip a step or 2 here. We get 8, which is a positive. Same thing with 1. There we have 16, which is also a positive. So part A is done. First derivative with the sign analysis. Part B, intervals on which the function is increasing, decreasing. If you remember, increasing is when the first derivative is positive, decreasing is when it's negative. So we're increasing actually in 2 sections, from -3 to 0, as well as from 0 to infinity. Decreasing, just the one section from -infinity to -3. C, the extrema, these are the minimum and maximum. We only have a minimum in this function. The only sign change we have is at -3, when we change from negative to positive. So no maximum, but we will have a minimum. Minimum is going to be at -3 comma something. What is that going to be? Well, we need to go back to the function, plug in -3, work that out. So that minimum is going to be at -3 comma -27. D, now we're looking at the second derivative. So the second derivative of this function, 12x squared plus 24x. To do the sign analysis, we need to find when this is going to equal 0. We can take a 12x out of that, split, we get x equals 0, x equals -2. On the number line, we'll have one spot at -2, one spot at 0. Second derivative will be 0. Need to pick one number in each of these regions again, and evaluate the second derivative at each of those to figure out whether it's going to be positive or negative. And again, I'm going to skip a couple of steps here. We plug in -3, we get out 36, so we are positive. Plug in -1. We get -12, a negative. And I'm going to do 1 over on this side. We get another positive. E, concave up, concave down. Concave up where the second derivative is positive. I'm going to abbreviate that CU. So we concave up from -infinity to -2, as well as from 0 to infinity. Concave down, second derivative is negative, so from -2 to 0. F, the inflection points, these are any sign changes in the second derivative that happen at 0, so we have an inflection point, one of them at -2 something, and another one at 0 something. We now need to find the y-coordinates of these points, so go back to the original function. F of -2 is going to give us -16. F of 0 is going to give us 0. G, the x and y intercepts. I always like starting with the y-intercepts, they're a little bit easier. Get the y-intercept, plug in 0 for x. We have a y-intercept of 0. X-intercept, plug in a 0 for y. Here what we can do is we can take out an x cubed, then split. We have two x-intercepts, one at 0, one at -4. H, the asymptotes, vertical asymptotes. Vertical asymptotes happen when we set the bottom of this function equal to 0. It's a polynomial function. It has no bottom. It's not a fraction. We have none. Likewise with horizontal asymptotes, take the limit as x approaches infinity. That only works when we have a rational function as well. So we have no asymptotes at all.